So I actually took up painting recently, and I don't know if you've ever tried this, but I kept agonizing over every single brushstroke on one canvas.
Right, trying to make it completely perfect.
Exactly. I was trying to make it perfect, and honestly, it was just exhausting. So I tried something completely different.
Oh, what did you do?
Well, instead of having an instructor critique a single attempt, I quickly painted 5 rapid variations of the exact same landscape.
Wow, 5 of them.
Yeah, just rapid fire. And by simply comparing them side by side, I instantly figured out which techniques worked and which didn't.
You know, what's really fascinating there is that you instinctively stumbled onto the power of relative comparison. Like, you bypassed the need for an external critic just by looking at the variance in your own work.
I didn't even think about it like that, but yeah, I guess I did.
And I mean, that exact mechanism is actually driving one of the most exciting, optimistic leaps in artificial intelligence right now.
It is wild to think that a human painting trick applies to machine learning, but today our mission for this deep dive is exploring exactly that.
Yeah, it's a breakthrough called Group Relative Policy Optimization, or GRPO.
GRPO, right. And it's letting AI models teach themselves complex reasoning, which is, unlocking this highly efficient, totally new era of problem solving.
It really is.
Yeah.
And to fully appreciate why GRPO is such a game changer, we have to look at the problem it actually solves. So previously, the standard for training large language models was something called Proximal Policy Optimization, or PPO.
Okay, right. So what was the actual bottleneck with PPO? Why do we need to move past it?
Well, PPO relied incredibly heavily on what's called a critic model. So think of it as a value network.
Okay.
To train the main AI, the actor generating the text, you essentially needed a second dedicated neural network of the exact same size just to evaluate the actor's output.
Wait, really? That sounds incredibly heavy.
Oh, it is massive.
It's almost like a brilliant author requiring a full-time, equally brilliant editor physically sitting on their shoulders 24/7.
That is a perfect analogy, actually.
And when the author's work scales up to hundreds of billions of parameters, I mean, the sheer computing overhead of carrying that editor around becomes impossible to sustain, right?
Exactly. You are effectively doubling your memory footprint and computing requirements just to grade the AI's homework.
Yeah.
And that scaling wall is where GRPO completely shifts the paradigm.
Which is famously powering models like DeepSeek R1, right?
Yes, exactly. It throws out that massive dedicated critic model entirely.
Okay, but wait. If you remove the supervisor network, isn't that just like a student grading their own homework?
Well,
If the AI generates 5 terrible answers, doesn't it just reward the least terrible one? How does it actually know it's doing a good job?
that is the crucial question right there. And it goes right back to your painting method. For any given prompt, the AI generates a group or, a cohort of candidate answers.
Okay, I'm tracking.
First, it calculates their raw scores using rule-based verifiers. Now, these aren't neural networks. They are hard-coded objective rules.
Like what?
So, for example, checking if a math equation evaluates correctly, or if a block of code actually executes without errors.
I see. So there actually is an objective baseline there.
Yes, there is. And then it compares those answers against each other using something called Z-score normalization,
Z-score normalization.
which is really just a fancy way of saying it grades on a curve.
Yeah.
It looks at the average performance of that specific group, rewards the answers that did better than average, and penalizes the ones that underperformed.
That is beautifully resourceful, just using its own outputs to find the optimal path. And actually finding highly resourceful ways to implement AI is exactly what our sponsor, Embersilk, specializes in.
They really do.
Yeah, if you need help with AI training, software development, or just uncovering where agents could make the most impact for your business or personal life, check out embersilk.com for your AI needs. They are absolutely fantastic at finding elegant solutions just like this.
And that elegance, it translates directly to the math behind GRPO.
Right, getting back to this grading on a curve idea, I understand checking if code runs, but how can simply comparing a small group of answers against each other replace a massive dedicated critic network for complex reasoning? I mean, doesn't the AI lose accuracy without that external editor?
It doesn't, actually. And it's all thanks to a brilliant statistical property called the U-statistic.
The U statistic.
Right? Think of it like guessing the weight of a cow at a county fair.
Okay, I'm with you.
If you ask one person, their guess might be way off. But if you take the average guesses of a group of 20 people, the group's collective guess converges on the exact right answer. The individual errors just cancel each other out.
Oh, wow. So the group itself basically becomes the oracle.
Precisely. Mathematically, as the size of the group of generated answers increases, this simple intra-group comparison creates an almost perfect baseline. The variance predictably decays.
That is amazing.
Yet you don't need a massive neural network to guess the value, because the group's own statistics reveal the absolute best path forward. It makes the training incredibly stable.
It's fascinating that by just removing the supervisor, the AI actually learns to think more critically on its own.
It does.
Because it's generating and grading its own varied attempts, this essentially acts as an automated curriculum, right?
Exactly. It allows the AI to spontaneously develop advanced chain-of-thought reasoning and self-verification completely autonomously. It's a massive leap forward.
It really is.
We are building highly capable systems that will help us tackle the world's most complex challenges far faster and more efficiently than we previously thought possible.
It's incredibly uplifting to see humanity finding such elegant, optimistic solutions to push the boundaries of knowledge. Which leaves me with a thought for you to chew on today.
I'd love to hear it.
Well, if AI unlocks its absolute deepest reasoning capabilities simply by generating multiple attempts and comparing them relative to one another, how might you apply that group relative thinking to supercharge your own daily problem solving?
That's a great point.
Right. Maybe instead of agonizing over a single perfect solution to a problem you're facing, you just need to paint 5 quick canvases and let the best ideas reveal themselves.
The best solutions often become obvious when we give ourselves the freedom to explore the variations.
I absolutely love that. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.